Welcome, folks, to the lesson on surface area of pyramids and cones. Very similar to finding the surface area of prisms and cylinders, except now we just have two different figures that we're using, okay? Same idea, surface area is still just finding all the different areas of the faces and adding them together. But now, again, like I said, we just have different solids that we're solving for, okay? So let's start by just kind of analyzing what a pyramid looks like and some things about it. So we have a regular pyramid and a non-regular pyramid. A regular pyramid would have a base that is a regular polygon. So like when we found areas of regular polygons, remember we took half the apothem times the perimeter, that would be like this guy here, okay? The bottom is a regular polygon, meaning all your sides are the same. Whereas a non-regular polygon is telling us that these are all different. All your sides are different. So what's nice about a regular pyramid is that once you find the base area, you just have rectangles that build it up that are all the exact same. Whereas for a non-regular pyramid, since your base is all different sizes, like the side lines, that means all the triangles that build up your pyramid would be different. We don't see a lot of those, but just know that's something that happens. Okay, slant height is the height of your lateral face. So if we look here, do you guys see how like this slant height is like coming towards the edge of our polygon? So that's like telling us the height of our lateral face. Whereas the height or altitude of the actual pyramid goes from the vertex down to the middle of your base. Now it's really hard to think three-dimensional on a sheet of paper, but just try to visualize it, okay? Try to visualize it. Okay, without further ado, let's just jump right into it. It says find the surface area. So we are starting off with a regular polygon, so a regular pyramid. Our base is a hexagon, so this would be a hexagonal pyramid. Okay, so we have to find the area of this hexagon, right? So if you guys remember, we're going to draw in our triangle here. I'm going to do it a little bit bigger here. Step 1, draw it in. Step 2, we got to find our angle. So 360 divided by the number of sides, which is 6, is 60. Divide that by 2 is 30. Yay! 30. And then this bottom here would be half of 5. So 2.5 is your short side. We need our apothem. So remember, take your short side times root 3. So 2.5 root 3. Well, that's approximately 4.3-ish. And now we should have everything we need to figure this out because, let's see here, our base area. We're going to take half our apothem, which is 4.3, times the perimeter of that hexagon. So if one side is 5, 5 times 6 gives us 30 times 30. Beautiful. Multiplying that all together, we should get 64.5. Lovely. Now we just define the triangular walls that build up our pyramid. So if we look here, I trace this out. Our base is 5, and they're telling us our slant height is 8. So it's just a triangle. So 5 times 8 divided by 2. So 5 times 8 is 40. Divide that by 2 and you get 20. And think we have 6 of those triangles, right, all the way around. So there's 6 sides, so there's going to be one here, here, all the way around. So that'd be 6 of them. So 20 times 6 gives us 120. So now our total surface area, we add them up. 64.5 plus 120. 184.5, what's our unit? Centimeters squared. Woo! Done. Let's try another pyramid. If they don't tell you like that it's a regular polygon on the bottom, if they don't tell you what this size, you can just assume it's 12. So what's nice on this one, we have a square pyramid. It's a square base and it's a pyramid, so it's a square pyramid. All right, let's start with our base area. So 12 times 12 gives us a base area of 144. Now let's find that lateral area. Ooh, so they're telling us that we don't have our slant height, but the good news is we can find it. So do you guys see how right now we're given our height or the altitude of our pyramid, but we need this guy. This is the one we want. We want that slant height. But what's nice is we just formed a right triangle there. So I know that this leg would be 16, but what would this be? It's not 12, but it's half of 12, so that'd be 6. And then we can do our Pythagorean theorem. So I'm going to put slant height. Slant height. And we're doing the Pythagorean theorem to find it. So let's see here. 16 squared plus 6 squared equals L squared. Crunch these out. 16 squared is 256. 6 squared is 36. Add them together, 292. How do you undo something squared? You take the square root. 17.1-ish. Are we okay with that? So now we can plug it in. So our base of our side here is 12. Uh-oh. We just found our slant height to be 17.1. And we'll divide it by 2 because it's a triangle. So if we crunch that out, we get 102.6. And how many sides or how many triangles build up that pyramid? Well, there's 4 sides to my base, so that means I'm going to have to take it times 4 for a total of 410.4. So now our total surface area, add up our base area and our lateral area. And we should get 554.4 centimeters squared. So really, you guys can do this. It's kind of a bit of a process, but you know how to find all these individual shapes, right? The areas of them. It's just a matter of not making a silly mistake and adding them together. Okay, let's move on to a cone. And again, there we go, cone. So again, we have a right cone and an oblique cone. They're very similar, except an oblique one is slanted to the side. We have a nice little formula to plug into, which we always love. So your base area, just a circle, right, folks? That's our circle. So pi r squared is your base area. And then your lateral area, it's weird. It's pi times your radius times your slant height. L is your slant height. I'd probably write that down. So again, if you don't know it, you'll probably have to do Pythagorean theorem to get it. But there is your slant height. It's the height of from the vertex to the edge of your base. It's your slant height. So let's try one of these quick, and then we'll be on. We'll be done for the day. Okay. So I'll write down our handy dandy formula: pi r squared plus pi r L. Let's plug in what we can. Our radius is 6, so pi. So one step ahead, that's all right. Pi 6 squared plus pi 6. 7 is not our slant height. 7 is the actual height. We got to find this guy. But again, it's just Pythagorean theorem. 7 squared plus 6 squared equals x squared. 49 plus 36 equals x squared. 49 and 36 gives us 85. Square root of that is about 9.2-ish. We go to 1 decimal place. So now we can plug in 9.2. And again, once you have your formula filled out, if you're really good at typing this in your calculator, type this whole thing in. You're good to go. If you're not very good at that, break it down just one more step. So 6 squared is 36. Well, 36 pi. 6 times 9.2 is 52. Oops, I lied. 55.2 pi. And then if you add those together, you should get what? Let's see, 91.2 pi. And now you can type that in, which is approximately 286.5 inches squared. Amazing. You guys are great. Good work today. Okay, that's all I have for you for now. Have a super rest of your day, and we'll see you in class. Goodbye.